Welcome to our video tutorial for question 5 of our daily review. And question 5 is working with scientific notation. We're going to be asked to convert back and forth from standard form to scientific notation. We'll also be asked to do some comparisons of numbers and determine maybe which number is bigger or smaller. So first, let's identify what scientific notation is. Scientific notation allows us to write, compare, and work with really large or really small numbers. Let's go ahead and talk about a few examples of why we might need to use scientific notation. Think for a moment about the size of an atom, right? Atoms make up everything around us, or even the size of an electron that would be even smaller, because an electron is something that makes up an atom. It's part of an atom. Well, for an atom, if I were to measure 1 centimeter, inside that 1 centimeter span, there would be 100 million atoms. So you can imagine how incredibly small the measurement for an atom would be. And again, like we said, an electron is even smaller because an electron is part of the atom. It's part of what makes up an atom. So just think about how small that number must be when we describe measuring an atom. Or we could also do the opposite. Let's think about something that's really large, something like the weight of the sun. In this case, the weight of the sun is enormous. I'm going to write it out just for dramatic effect so that we can see how incredibly heavy the mass of the sun is. And you can see that this is an incredibly large number. I don't even know how to say this number, it's so big. In fact, there are 28 zeros to this number. It is a huge number. And imagine trying to write that down a bunch of times, or trying to work with that number, or even trying to make a comparison. Imagine comparing that with something that had 26 zeros. You certainly couldn't identify or tell right away without lining them up or making sure everything was perfect, which number was bigger or smaller. So scientific notation really helps us to work with those numbers that are incredibly large or incredibly small. Let's go ahead and do some examples of scientific notation, and we'll learn the process to convert from standard form to scientific notation. Let's start with a big number, although this certainly isn't as large as the mass of the sun, but we'll start with 938,000. If I wanted to write it in scientific notation, it would look like this. I would write 9.38 times 10, and then I'm going to do an exponent. And I'm going to do that exponent based on how many places I needed to move that decimal. In this case, I would have moved the decimal 5 spaces, so my exponent would be to the 5th power. So here's our rules for how we would write in scientific notation. The ones place value is always going to be that first non-zero digit. In this case, it was 9, so we used 9 in that ones place value. Now, it's also really important that you remember that that first digit is always going to be a number 1 through 9. It will never be 0, and it will never be 10 or 11 or 12, because it can only be the ones place value. So it's always going to be that first number that shows up 1 through 9. Our next rule tells us that we're going to use the decimal, and then we're going to use or include all of the non-zero numbers that are after that first digit that we used. Now, there's a slight exception to this that we'll describe here in a few minutes, but in general, if you remember this, you'll be okay. We are always going to multiply by a factor of 10, and we are always going to raise to the power or find the exponent of how many spaces we needed to move the decimal. In this case, we moved it 5 spaces, and so we raise it to the 5th power. Let's go ahead and do another example, and we'll keep these rules up here so that we can walk through them together. Here we have 351,680,000, a little bit bigger number. My first step is going to be to write the ones place value. Remember, it's always going to be that first non-zero digit. Then I'm going to write a decimal and include all of the non-zero numbers that were after that first digit, or in this case, after the 3. So I'm going to write 3.5168. Notice this number had significantly more numbers after the decimal than our last example, and that is totally okay. Next, we're going to multiply by 10. And finally, we're going to identify how many spaces we needed to move the decimal to take 351,680,000 and turn it into 3.5168. In this case, I've moved the decimal 8 spaces, so I'm going to raise my exponent to the power of 8, or raise the 10 to the power of 8. Now I wanted to look at another example, and this talks about that exception that I described a moment ago. Remember, we're going to always include the first non-zero digit. In this case, there's a common mistake that some students make. Some students might be tempted to write down 10.567, but notice that that's not a one-digit number. It's not a number 1 through 9. So we actually have to make an adjustment here. And we need to turn this into a one-digit number. And we said that second step, we're going to always include all the non-zero numbers, but you're going to see we have a 0 there. And that's because we're going to include any numbers that are between my first digit and the last non-zero digit that's there. So in this case, we have 1.0567. We can't just leave that 0 out, or else we're changing the number. We're still going to multiply by a factor of 10. And then we need to identify how many times we've moved the decimal to get this new number. In this case, we had to move our decimal 6 times. So we end up with 1.0567 times 10 to the 6th power. Now, before we move on, and we will do some examples with decimal numbers, or those really small numbers, in just a moment, I want to make sure you recognize that you could also undo this exact same process. You could do the reverse to take a number from scientific notation and turn it into standard form. Essentially, you're determining how many zeros do we need to put at the back of that number. Let's go ahead and look at a really small example. So here's a number that includes a decimal number, and our process is exactly the same, except for we have one change that we'll make at that last step. So our first step is I'm going to write down the first the first non-zero digit. In this case, that's going to be a 3. I'm then going to include my decimal, that's any of the other non-zero numbers that are there. I still am going to multiply by 10. And this time, I'm going to notice that I'm moving my decimal in the other direction. In this case, I moved it backwards 1, 2, 3, 4 spaces. So I'm going to raise to a power of 4, but I need to show that it's going the other direction. So I'm actually going to raise to the power of -4. Now, let's go ahead and just talk about how we can use scientific notation to do some of those comparisons of numbers that we described just a moment ago. In this case, we could take a look at a number like 3.675 times 10 to the 3rd power and 3.675 times 10 to the 2nd power, and we should be able to identify right away that 3.675 times 10 to the third power is the bigger number. And I can tell that right away because the exponent is a larger exponent. If I were to change both of these numbers from scientific notation to standard form, I would end up with 3,675, or I would end up with 367.5, and we certainly know that 3,675 is greater than 367.5. Let's do another comparison here. In this case, I have 2.8 times 10 to the 12th power, and I have 7.9 times 10 to the 4th power. In this case, I notice that the number on my right-hand side might look a little bit bigger. 7.9 looks like a bigger number. But when I pay attention to that exponent, I can tell right away, really easily, that 2.8 times 10 to the 12th power is going to be a much larger number. And we could do the same thing with our exponents, with our decimals here for our scientific notation. Here I have 4.19 times 10 to the negative 8th power, and I have 2.17 times 10 to the negative 4th power. In this case, we're going to know that 2.17 times 10 to the negative 4th power is going to be our larger number. That gives you a sense of how to work with scientific notation, convert to and from scientific notation, and to compare some numbers using scientific notation.